In this video, we're going to take a look at how to find the vertical asymptotes of a function. All right, so we have a function here, f of x equals x minus 2 over x squared plus 3x minus 10. So when you have a function like this, what you want to do is to set the bottom part equal to 0 and solve that resulting equation. And what that will give you is the possible vertical asymptotes. So you need to be a little bit careful about that. A lot of times people will just assume that every solution of setting the bottom equal to 0 and solving will give you a vertical asymptote, but that's not true. That will only give you the possible ones. So then you would need to go through some process to check to see if there's actually vertical asymptotes there. All right, so the bottom part here is x squared plus 3x minus 10. We're going to set that equal to 0 and solve that. That's just a quadratic equation. This one can be factored, right, to x plus 5 times x minus 2. Okay, and so the left side is completely factored and the right side is 0. So that's saying that x plus 5 times x minus 2 is equal to 0. So the only way that is going to happen is if either x plus 5 is equal to 0 or x minus 2 is equal to 0. So solve each of those equations for x, and on x plus 5 equals 0, if I subtract 5 from both sides, it's going to give me x equals to negative 5. And if I add 2 to both sides here, I'll get x equals 2. Okay, so I have two solutions to that equation, negative 5 and 2. So there are possible vertical asymptotes at negative 5 and 2. And so what I need to do now is to just double check to see if there are actually vertical asymptotes there. So in this class, we've defined the vertical asymptotes as in terms of limits, right? So what we're going to need to do is take the limit as x goes to negative 5 and as x goes to positive 2 to figure that out. So let's start off with the limit as x goes to negative 5 from the right. Right? If you recall what we've done in the past, you can either take the limit as x goes to negative 5 from the left or x goes to negative 5 from the right. And that will also tell you information about the two-sided limit. So we're going to start with the limit as x goes to negative 5 from the right. So if we plug in the negative 5 in for x and start simplifying that out, we are going to get negative 7 on top and a 0 on the bottom. So that will tell us that the limit is either infinity, negative infinity, or does not exist. So for a rational function like this, the one-sided limit is going to come out to be infinity or minus infinity, but we're just going to work through the rest of this part just to verify that. So what we would do, if you recall from how to solve infinite limits, is we would take the bottom part, right, and find where it's positive. And so in doing that, we would set the bottom part equal to 0 and solve that out. Well, we've already done that when we were finding the possible vertical asymptotes. So we know that the sign diagram for this function is going to have a negative 5 and a positive 2 on it. And in this particular part, we're concerned about the limit as x goes to negative 5 from the right. So we're going to pick a test point in between negative 5 and 2. I'm going to pick 0, and we are going to take the bottom part and put that 0 in for x and solve that out, and we would get that we would get a negative 10 there. So what that means is that if I plug 0 into the bottom part of this function, I'm going to get a negative, and also if I take any number in between negative 5 and 2 and plug that into the bottom part of this function, I'm going to get a negative number. So to indicate that, you just put a big negative over the interval there. All right, so that will let us decide what the limit as x goes to negative 5 from the right is. When I plugged in, I got a negative 7 over 0, right? And from the sign diagram, I can tell that, well, the top is obviously negative, right? And then as I am going to negative 5 from the right, from the sign diagram, I know that numbers just to the right of negative 5 would also be negative when I plug them into the bottom. So I have a negative divided by a negative, right, which would be a positive. So the answer here is that That limit as x goes to -5 from the right is positive infinity. Okay, so that tells us that just by the definition of vertical asymptote that we had, that x equals -5 is a vertical asymptote of this function. All right, now we need to check the limit as x goes to 2 of x minus 2 over x squared plus 3x minus 10. And here I'm taking the two-sided limit, but you could also do right side or left side. It's not really going to make any difference on this one. So on this one, I'm going to go ahead and plug the 2 in and see what I get. So when I do that, I get 0 on top, and then I get 4 plus 6 minus 10. So I wind up with 0 over 0, right? The indeterminate form here. So at this point, you might think, okay, let me jump to, you might be tempted to jump to conclusions that there is no vertical asymptote here, but you can't do that in general. Sometimes if you do that, you'll get an incorrect answer. So what you need to do is just to work through this problem just like you did for in the previous sections about the indeterminate form 0 over 0. So for this particular example, what you want to do, we have that function that we started with, and again, the bottom part can be factored, right? X squared plus 3x minus 10. We already did that. It factors down to x plus 5 times x minus 2. And so when we do that, now we can see, hey, there's a common factor in the top and in the bottom. And what we would do is to go ahead and cancel out that common factor. When we cancel out that common factor, we get the limit as x goes to 2 of 1 over x plus 5. And now when we substitute the 2 in, we wind up with a value of 1/7. So the limit as x goes to 2 of this function will be 1/7, right? So it comes out to be a number in this case. And so what conclusion can we make about that? Well, that would mean that the line x equals 2 is not a vertical asymptote of the function. Okay. So the only vertical asymptote that this function has is x equals -5. So again, don't jump to the conclusion just because you get to the 0 over 0 part, right? Just because you get to that does not mean necessarily that there's no vertical asymptote at that number, but because it could happen that you cancel out the common factor and you still get non-zero over 0. So you just have to completely work this part out and see what answer you get. In this case, we got 1/7, right? So going back to the definition of vertical asymptote, right? There was a vertical asymptote if either the one-sided or two-sided limit was infinity or minus infinity. And here they're all equal to 1/7, so there is no vertical asymptote here.